Welcome to Advanced Learning Tutoring. This is the chemistry playlist. Please like this video and subscribe to our channel. Conservation of mass. The law of conservation of mass states that no atoms are lost or made during a chemical reaction. So the mass of the products is equal to the mass of the reactants. An example chemical reaction is methane plus oxygen forming carbon dioxide and water. If the methane and oxygen have a total mass of 100 grams and the product carbon dioxide has a mass of 60 grams, for example, it must mean that the remaining mass of water is 40 grams, as the total must be 100 grams, equaling the reactant mass. Relative formula mass. The relative formula mass of a compound is the sum of the relative atomic masses of atoms shown in the formula. For example, water has the formula H2O, meaning 2 hydrogen atoms and 1 oxygen atom form water. Each hydrogen atom has a relative atomic mass of 1, and each oxygen atom has a relative atomic mass of 16. Therefore, the 2 hydrogen atoms have a total mass of 2 plus the 1 oxygen atom of a mass 16 equals 18, being the total relative formula mass of water. Another example being carbon dioxide. Carbon dioxide has the formula CO2, meaning 1 carbon atom and 2 oxygen atoms form carbon dioxide. Each carbon atom has a relative atomic mass of 12 and each oxygen atom has a relative atomic mass of 16. Therefore, 12 plus 2 lots of 16 give a total relative formula mass of 44. Moles. Moles are a measurement of an amount of substance. The mass of 1 mole in grams is equal to the relative formula mass. The number of atoms, molecules or ions in 1 mole of substance is given by the Avogadro constant. 1 mole of any substance is equal to 6.02 times 10 to the power of 23 atoms, ions or molecules. It is important we understand how to use moles in chemistry. As atoms and compounds are so small, it would be very difficult to do complex calculations in chemistry looking at the number of atoms in an amount of substance. The numbers would just be too large. So we equal 6.02 times 10 to the 23 atoms to 1 mole of substance. To calculate moles, you divide the mass in grams by the relative formula mass of the compound. Example calculation: how many moles are there in 88 grams of carbon dioxide, CO2? Well, moles equal mass divided by relative formula mass. Therefore, moles equals 88 grams divided by 44. The 44 being the relative formula mass of CO2. 88 divided by 44 equals 2 moles. Therefore, 2 moles of carbon dioxide would equal 2 times 6.02 times 10 to the power of 23 molecules. Using moles to balance equations. When looking at a balanced equation, you are essentially looking at the number of moles of one substance as a ratio of the number of moles of another substance. An example: 8.1 grams of zinc oxide with the formula ZnO reacts completely with 0.6 grams of carbon, formula C, to form 2.2 grams of carbon dioxide, formula CO2, and 6.5 grams of zinc, formula Zn. Write a balanced symbol equation for this reaction using moles. First, we want to calculate the relative formula mass of any substance. Look at the relative atomic mass of each element from the periodic table. Zinc has a relative atomic mass of 65, oxygen 16, carbon 12. To calculate moles of each substance, you do the mass divided by the relative formula mass of that substance. In doing this, we find the moles of zinc oxide to be 0.1, moles of carbon to be 0.05, moles of carbon dioxide to be 0.05, and moles of zinc to be 0.1. Looking at this, we see that the moles of carbon and the moles of carbon dioxide are the same. That means the ratio of carbon to carbon dioxide is in a 1-to-1 ratio. To find the smallest whole number ratio, you divide all the moles by the smallest number of moles calculated. An example, zinc oxide would be 0.1 divided by 0.05, giving you 2. 0.05 divided by 0.05 would give you 1. Therefore, we have 2 moles of zinc oxide, 1 mole of carbon, forming 1 mole of carbon dioxide and 2 moles of zinc. Balanced formula equations are incredibly important in chemistry, as you can use balanced symbol equations to work out the amount of substance in grams that you are expected to produce in a chemical reaction. To note, looking at a balanced symbol equation, if you have a molar ratio, the ratio of the number of moles, as a 1-to-1, this is a molar ratio, not a ratio of masses. Limiting reactants. It is common to use an excess meaning more than you need, of one reactant to ensure the other reactant is used up. The reactant that is completely used up is called the limiting reactant. It limits the chemical reaction. It will limit the amount of product that you can form. An example: calculate which is the limiting reactant when 10 grams of calcium carbonate reacts with 50 centimeters cubed of a 2 mole per decimeter solution of hydrochloric acid. At this point, you want to calculate moles of each substance. A reminder that moles are calculated by doing mass divided by the relative formula mass. So calculating moles of calcium carbonate, you do the 10 grams divided by the relative formula mass of calcium carbonate, which is 100. 10 divided by 100 gives you 0.1 moles. The moles of hydrochloric acid, because it's a solution, you do the concentration multiplied by the volume in decimeters cubed. The concentration is 2 mole per decimeter. You multiply this by the 50 centimeters cubed. First, convert it into decimeters cubed by doing 50 divided by 1000. So 2 multiplied by 50 over 1000 will give you 0.1 moles of hydrochloric acid. To now see which is the limiting reactant, you write the balanced equation. CaCO3 plus 2HCl forms CaCl2 plus CO2 plus H2O. This is a neutralization reaction. Calcium carbonate is a base. When a carbonate reacts with an acid, you produce salt, carbon dioxide and water. There is 1 mole of calcium carbonate and 2 moles of hydrochloric acid, the ratio being 1-to-2. Now, in our calculation of moles, we have 0.1 moles of calcium carbonate. As the ratio is 1-to-2 of calcium carbonate to hydrochloric acid, you multiply the moles of calcium carbonate by 2 to give us 0.2 moles of HCl. So for every 0.1 moles of calcium carbonate, you require 0.2 moles of hydrochloric acid to react completely with it. We don't have 0.2 moles of hydrochloric acid. We only have 0.1 moles. Therefore, there is not enough hydrochloric acid available to react with the 0.1 moles of calcium carbonate. This means that the hydrochloric acid is the limiting reactant. The calcium carbonate is in excess as we have more than we need. Concentration of solutions. The concentration of a solution can be measured in mass per given volume or moles per given volume. Think about if you are making a cup of coffee and you put a spoonful of your coffee granules into water. This is a solution. The mass of the coffee granules would be in grams, the volume of the water that you put the coffee in decimeters cubed. You divide these numbers and you calculate the concentration of your cup of coffee. A key point to note is the conversion between centimeters cubed and decimeters cubed. 1 decimeter cubed is the same volume as a litre, and a litre is 1,000 centimeters cubed. So to convert centimeters to decimeters cubed, you first divide the volume in centimeters cubed by 1,000. Example being 500 centimeters cubed is half of 1,000 centimeters cubed, so 500 divided by 1,000 gives you a volume of 0.5 decimeters cubed. Calculating concentration, you do mass divided by volume. An example, what is the concentration of 6 grams of copper sulfate in 500 centimeters cubed of solution? 6 grams divided by your volume in decimeters cubed. 500 divided by 1,000 is 0.5 decimeters cubed. So 6 divided by 0.5 gives you a concentration of 12 grams per decimeter. Percentage yield and atom economy. Percentage yield. It is not always possible to obtain the calculated amount of a product in a chemical reaction. This may be due to the reaction not reacting completely, or it may be reversible. Some of the product is lost in separation, remaining on the equipment, or that some reactants may react in different ways, or the reactants are impure, so side reactions occur. To calculate percentage yield, you do the actual yield you obtain, divide that by the theoretical yield you have calculated or that you expected to obtain using a mole calculation, and multiply that answer by 100. An example to think of is when you bake a cake and you mix your ingredients together, the reactants, you put your cake in the oven and you weigh your final product. The weight of the cake would probably be less than the weight of all of the reactant ingredients added together. This is due to some of the product perhaps being lost on the mixing bowl. Atom economy, a measure of the amount of reactants that end up as useful products. A higher atom economy is preferred in industry, more useful product formed versus less waste product. To calculate atom economy, you find the relative formula mass of the desired product, you divide this by the sum, the total, of relative formula masses of all reactants, and multiply this by 100 to get as a percentage. A chemical reaction with only one product would have an atom economy of 100%, as there are no other products in the chemical reaction. Concentration in moles per decimeter. Mole per decimeter concentration can be calculated by doing the number of moles of substance divided by the volume in decimeters cubed. we recall the conversion of centimetres cubed to decimeters cubed by dividing your centimetre cubed volume by 1000. 1 decimetre cubed is equal to 1000 centimetres cubed. An example of a calculation of concentration. 30 centimetres cubed of 0.1 mole per decimetre of sodium hydroxide reacts completely with 35 centimetres cubed of hydrochloric acid. The reaction is in a 1:1 ratio. This means for every 1 mole of sodium hydroxide, you require 1 mole of hydrochloric acid to neutralise it completely. Calculate the concentration of hydrochloric acid. To calculate the concentration of HCl, you need to know the moles and the volume. You know the volume is 35 centimetres cubed, but at this stage you do not know the moles. So we refer to our balanced symbol equation. We don't yet know the moles of sodium hydroxide, but we are able to calculate them. Calculate moles from a solution by doing the concentration multiplied by volume. The concentration of sodium hydroxide is 0.1, and we multiply this by the volume of sodium hydroxide in decimeters cubed. So that is 0.1 multiplied by 30 over 1000, and that is equal to 0.003 moles. The reaction is in a 1:1 ratio with respect to sodium hydroxide and HCl. Therefore, the moles of HCl required are also 0.003 moles. Now we know moles and volume of HCl, you can calculate the concentration by doing moles divided by volume. 0.003 divided by 35 over 1000 equals 0.086 mole per decimetre cubed concentration of HCl. Volumes and moles of gases. Any gas will occupy the same volume under the same conditions of temperature and pressure. The volume of 1 mole of any gas at room temperature and pressure is 24 decimeters cubed, or 24,000 centimeters cubed. An example calculation: what volume of gas will be occupied with 2 moles of carbon dioxide at room temperature and pressure? If 1 mole of any gas occupies 24 decimeters cubed, 2 moles of gas must be equal to 2 times 24, which will equal 48 decimeters cubed.